Hello, and a very warm welcome to the part 2 of the Dataflow ML demo. I hope you liked part 1 of the illustration, where we added one of the most intriguing NLP come ML applications called word clustering by achieving it in a data processing pipeline. If you haven't already, please do check it out. There we use Dataflow ML in order to handle spacey and scikit-learn models sequentially. As already promised, we'll visualize the P collections obtained in part 1. We'll also export the entire pipeline as a Dataflow job. Hope you find this demo interesting as well. Now let's move ahead with the demo. This interactive beam JupyterLab extension interactively inspects the state of pipelines and data associated with each P collection. This extension can be manually installed as well. More details in the description below. Now click on the Interactive Beam tab, click on Open Inspector and select the kernel for your notebook. So fetch words indicate the process of extraction of the words from the CSV file. Then these are passed through the run inference spacey operation in order to generate their 300 dimensional word embeddings. Then run inference scikit-learn comes into picture for clustering these 300 dimensional vectors for each and every single word. Finally, these clusters are reported, visualized, and analyzed. If I click on spacey-df PCollection and check the box corresponding to visualize and facets and click on apply, I can see all the 196 circles which are indicating the words taken into consideration for the testing purpose. Clicking on any one of them tells you the word it actually contains. Now let's click on spacey-df1 PCollection in order to visualize the 300 dimensional vectors. So these circles contain the first value of each 300 dimensional vector created for 196 entries. Various statistical parameters such as mean, standard deviation, median, and minimum and max values are also computed. At last, let's click on scikit-learn df PCollection, and this will indicate all the cluster assignment. So if I set the label by as inference, we can easily observe the cluster assignment. If I set the x-axis as inference, we can visualize how many words are assigned to cluster 0, 2, 1, and 3. Similarly, you can also set y-axis bidding as inference and have a lot of fun trying out different options and visualize the changes in the output. If I set the color by as example and click on any one of the circle, it indicates the vector corresponding to that particular circle. And if I visit the spacey-df PCollection again, you can see that the corner circle actually corresponds to the word Google, which is assigned cluster 2 for tech. Let's get back to the notebook. As already mentioned, all of these visualizations could be generated through Apache Beam Interactive Beam module as well. We can easily observe how convenient it was to use the Interactive Beam tab over the programmatic approach when you want to control the parameters like window size, etc. We'll now launch a Dataflow ML job from the clustering pipeline we just built. As is customary, let's start with all the necessary imports. Here we set up the required pipeline options and GCP project. The command gsutil-mb creates a standard class multi-regional US bucket. Also, we specify the region, the GCS staging location, and a temporary location for Cloud Dataflow to run. Then, we can specify the directory to store the output files of the job. By executing the below code snippet, we can see our Dataflow job up and running in the GCP console. Now click on this link. Here we can observe the Dataflow pipeline graphically and in tabular format as well. Congrats, you did it. Clicking on each step mentions you its details, such as status, stages, and input steps. If we get back to the graph view, you can click on the drop down arrow on each of the blocks. If you click on fetch words, it tells you it's a read operation. As of now, we can see that none of the stages have succeeded. These words are written to a file in the cloud storage. The run inference spacey block consists of two operations, including beam-ML run inference. Similarly, run inference scikit-learn block also contains two stages, which are yet to succeed. This is a print clusters block responsible for displaying all the resultant clusters. This time, instead of words, the inference results in the form of vectors and clusters are written to the file in the cloud storage. If I click on execution details and stage workflow, the execution stages of this Dataflow ML job are represented in the form of workflow graph. If I click on worker progress, we see that no graph is available as of now, since none of these stages has succeeded till now. We finally see some stages getting succeeded, If any error occurs while the Dataflow job runs, it can be checked under the log section for troubleshooting. It's super awesome to see all the stages successful in the Dataflow pipeline. If I get back to the tabular view, all the stages are completed successfully. This is stage workflow diagram indicating completion of all stages. Now if I click on worker progress, we can see the worker details such as work attempt ID and its duration. Under the job metrics section, we can check CPU and memory utilization as well as throughput. Now we'll run some commands to access Google Cloud storage from the notebook itself. From the command line, you can access cloud storage through gsutil, a Python application. You can verify the directory and the file content by executing the following commands. Three folders, namely output, staging, and temp, are created inside the folder demo. We have performed write operation to the two.txt files placed inside the output folder. If I display the content of all of the files in this particular directory, it shows all the inference results as well as the words. If I get back to the GCP console, click on Cloud Storage and Buckets, I could see there is a bucket with the name Dataflow ML bucket AA demo. We'll click on it. Click on Demo folder. We'll verify the content of each and every single folder, starting with temp, followed by staging, and most importantly, output. We are able to see two files with all the details. We'll click on the file. If I click on the authenticated URL for the file, I'll be easily able to check its contents. The similar argument holds true for the first file as well. And there it is. We can see the file populated with the inference results, and this sums up our work on the GCP console. Let me get back to the notebook again. And if we revisit the graph generated by the Apache Beam Interactive Beam module, so we can easily see that all the run inference operations are occurring in a sequence. But if I rerun this code, so if you observe, there are two changes. The write operations to the cloud storage also do occur in the pipeline. This is the consequence of the export of this pipeline as a Dataflow job. Enjoy exploring and playing around with the other options that the console has inbuilt for you. The link for the Google Cloud Medium blog with all the code snippets is mentioned in the description below. Let's recapitulate what we learned. We understood the importance of word clustering in real life use case scenarios. We got to see how powerful Dataflow ML is for building scalable pipelines for handling ML models sequentially. And last but not the least, NLP and ML capabilities of powerful libraries like Spacey and scikit-learn are witnessed as well. Should you require more details or specifics regarding what is discussed, refer to these documents towards my left hand side. We hope you found it informative and useful. For any further comments or queries, please feel free to reach out. Till then, thank you, adios, and see you soon with another video.